Programming feels like I have a superpower. I create anything I want. If there's an idea, I could bring it to life using programming. I believe technology can impact life, and technology is a story about us and how we changed our life from the invention of the wheel to modern-day computers. 2 years back, when I was in 10th standard, I came across an incident that would change my life. On coming home from school, I witnessed the accident of a visually impaired person. And this prompted me to look into the lives of the visually impaired. See, most visually impaired people use rudimentary instruments like walking sticks to move around in the environment. So I thought to myself, what could I do? So I came up with a solution. I came up with a device that would help guide the visually impaired. The device consisted of a camera and a earphone. The camera would scan the environment and signal the user about any danger like potholes or even traffic lights. A lot of my peers felt programming a bit complex, so I want to break that down too. So I authored a C++ book, which has become an all-time favorite for several universities across Bangalore and abroad. My love for programming and technology motivated me to use technology, a deep learning, machine learning course online. There are tons of material out there, and anyone could learn anything from the internet. Last year, I also visited Harvard University, and I conducted research over there. I believe mathematics is the language of nature, and exploring it is the key to solving our problems. So in the end, I published nearly 22 theorems, which is presently on the Harvard Math website. Moving forward, I shall begin with the latest project of mine. If you notice, the human brain cells, the universe, and the internet all have something in common. They are all made up of similar structure. And I believe decoding the human brain is possible through computers. Decoding the human brain is one way of solving one of all the world's biggest problems right now, from suicide to poverty. The truth is, computers are really efficient at finding patterns. And our brain follows a specific pattern when it functions or does work. So by using computers, we can find that pattern and artificially simulate it on a computer and also understand how the human mind works. And we can do that using deep learning technology. So what is deep learning technology? So deep learning is vaguely inspired by how the human mind works. What we're trying to do is build artificial neurons on a computer and help make it solve our problems. Right now, millions of devices use deep learning technology. In fact, the very application that I use to come to this event uses deep learning to navigate and find the fastest path to this hotel. Now, although deep learning would have immense impact in a wide variety of fields, I believe its biggest impact would be in the field of healthcare. And why do I say this? Mainly because of the huge amounts of data the healthcare industry produces alone. In 2013 alone, 153 billion gigabytes of data were produced. So at this astronomical rate of 48% growth annually, in 2020, we would have 14 billion gigabytes of data. That's huge. So what could we do with this huge amounts of data? As I said earlier, computers are really efficient at finding patterns. And we can use computers to analyze and find correlations in this huge data set. To further illustrate this more, let's take an example. Let's say there's a series, say 1, 2, 3, dash, dash. Who will think that the next number would be 4? And the next number would be 5? Well, according to one perspective, that might be correct, but since I said the question, it is wrong. The actual answer is 1, 2, 3, 5, 8. So even if I'd given you one number, say 5, you would have guessed the remaining series, 1, 2, 3, 5, 8, and so on. So greater the amount of greater the amount of data we have, greater is the accuracy of finding the pattern. Moving on, I would like to introduce you all to one of the biggest projects that I worked on that I believe would have an impact in the field of healthcare. I would like to introduce you to Project Health. By the raise of hands, how many of you know a person who is suffering from a neurological condition? Okay, that's a lot of people. In fact, even my grandfather was suffering from a neurological disorder called Parkinson's. And this disease fascinated me. And his early demise was due to the late diagnosis of this neurological disease. So I thought to myself, what could I do? Is there any non-invasive way I can speed up the diagnosis or recovery for these kind of neurological disorders? Turns out it's in fact possible to do this, to accomplish this task. And you can do this using computers. See, millions of people suffer from diseases like these all across the globe. And most symptoms are, for diseases like neurological disorder, it takes quite a time for the actual appearance of the symptoms after the onset of the disease. In a vast country like India, we have access to healthcare is limited and is also expensive. So most people don't even visit a doctor to understand and go for regular checkups. And also, another problem is the slow progressive property of these kind of neurological disorders. So how do we counteract these problems and find a solution? So I thought to myself, what could I do to decrease diagnosis time and also provide better patient care and also provide feedback for the type of medication that has been provided? The answer lies with machines. See, machines can diagnose diseases accurately. My innovation uses data like body behavior to find patterns and accurately predict when the disease is going to occur, so that I could help curb this disorder of Parkinson's. And it has an accuracy of greater than 92%. Not only this innovation can help curb the problem, it also reduces the error rate and enhances doctor-patient ratio as well. Let's take an example. Say a person is suffering from Parkinson's, and one of the symptoms of a Parkinson's disease is tremors, rapid movements. So all the person has to do is wear a wristband, and it would record his data. If there's any inconsistency in the regular pattern of movements, it would alert, and the patient can seek medical care and probably could save his life. According to an article published by Times of India, right now the current state in our country is 1 doctor for every 921 patients. Everything starts with little steps, and I hope I have done one part in this. The health project is not only going to help change the way people are getting diagnosed, but also help provide better medication and also enhance this doctor-patient ratio. My aim is to build more projects like these to make an impact in the world. See, humans are extremely smart beings, and training computers to our level is not that far away. And I hope by next decade, or less than a decade, we are going to achieve this feat. Another project that I have put for this event is Project Life. Right now, a big problem is existing in the field of mental health care. A very big problem. I'm talking about suicides. Nearly 800,000 people commit suicides every year. And so sadly, by the end of this talk, nearly 22 people would have taken their lives all over the world. In fact, suicide is the second leading cause of death for 15 to 29-year-olds. So why is suicide so hard to curb? Is it invisible? We humans are not really good at recognizing symptoms displayed by suicides or depressive people. Say, for example, a person is suffering from common cold, and he is coming with you coming to you with a runny nose, and you will know for sure that he is suffering from common cold. But the symptom displayed by depression is not as obvious as a runny nose. Most people wear a mask to hide their real emotions. We humans are complex beings, and we display emotions that are not original in original self. We display artificial emotions. A person who's cheerful outside might not necessarily be cheerful inside or happy inside. However, machines are pattern finding geniuses. So if a human can't detect whether this person is suffering from depression or not, or whether this person is sad or not, why not use machines? So why not use a machine to detect the emotional state of a person? Right now, we do have solutions to help curb the problem of suicides. For example, we have suicide hotlines and mental health workers. But in a vast developing country like India, some of these suicide hotlines are not 24/7. Moreover, mental health workers are scarce too. And what if the person doesn't ask for help? To answer that question, we need to answer ourselves, why won't a person ask for help? There may be many reasons for which the person might not be comfortable in sharing his feelings, but one of the biggest challenges is social stigma. A lot of these people are, say a person who is depressed, you might not be feeling to talk to him because the society is set like that, and it has been going on for millions of years. Another problem is access to mental health care is expensive. In fact, in 2015-2016, 70 to 92% of people in India, depending upon the state, had zero access to mental health care treatments. That's zero people. So how do we curb these problems? We can answer lies with machines. Since computers are really efficient at finding patterns, and we exhibit behavioral changes when there is changes in our mind, and we exhibit subtle changes when there's change in our mind, which is not comprehensible by we humans, a machine is far more better at these kind of analyzing data points. Moreover, we carry devices everywhere. For example, the smartwatch or the smartphone, and we record our data. However, most of the data is not analyzed. We can track and analyze these changes and also find correlations between the cause and effect and predict what's going on inside the human mind. And we can do that using deep learning. The human brain solves problems very efficiently. Millions of years of evolution has done that. And we're trying to simulate that kind of efficiency on a computer. And it's going to take a while. And since we carry devices that record our behavior, for example, the amount of steps you have taken, and from calorie burnt to the heartbeat, and also your sleep analysis. How many of you use a phone to track how much amount of sleep you have been receiving every day? We can analyze all these behavioral data to predict the emotional state. We can find any small inconsistency in the regular pattern and predict what kind of emotional state this person is, or what is he doing, or what is he suffering from. Since we carry all these data points, it's easier for us to build an application around all these data points and analyze these data and find correlations. Let's go back to an example to illustrate this better. Let's say a person is sleeping regularly at 10 p.m. and he gets up at, say, 8 a.m. So he's getting a compulsory 10-hour sleeps regularly. But if he is depressed, he might not sleep for 10 hours. He might sleep for 4 hours, or he might not sleep at all. So you see, there's a slight change in the regular pattern, and that's what we are looking for. And that's what we are training machines to look for and signal the user. All we're doing is finding correlations between sleep time and mental state. Another problem in doing this project is noise involvement.